Hello, so today we're going to be beginning our unit on transformations in packet 10, lesson number 44. So if you flip open your packet, we have a quick do now. What is a reflection and what are some examples of reflections in real life? So take a minute to think about it, jot down any ideas. You could pause this video while you do so and then come back. So what a reflection is it's a mirror image. Some examples of reflections in real life. A lot of people said mirrors. People also said water. So like if you're walking past like a puddle of water or a pond and you look in it, you might see your reflection or, the picture of you in there. Other people had said windows. And there are plenty other examples that you can come up with where you might see a reflection. So reflection is a mirror image, otherwise known as like a flipped image. Of something. So it really is the same thing as it's the same exact picture, it's just flipped. Some of you might notice when you take a selfie, you're also doing a mirror image of yourself, just flipped the other way. So if we look at this diagram down here, we see that we have this triangle, ABC, and it's reflected to create triangle A prime, B prime, C prime here. So triangle ABC is the one that comes first. When we have an image that comes first, we call this our pre-image. It's the one that's there previous to the reflection taking place. So this one, just ABC, is the one that comes first. And we call this our pre-image. Then we have this next triangle, A prime, B prime, C prime, which is the one that comes second, which is just our image. We know that it's the one that comes second because it has these little tick marks that we pronounce as prime, and you've been hearing me say A prime, B prime, C prime. So this one came first and this one came second. So then what would triangle ABC be reflected over to get us to get to A prime, B prime, C prime? So what you notice here is we have this x-axis, and that's what it's being reflected over. So if we take a look here, A prime, B prime, C prime's here. If I flipped it, ABC, I'm sorry, is here. If I flipped it, I get A prime, B prime, C prime. So it's being reflected over the x-axis. So then what I want you to do is I want you to take a second now. We're going to analyze the coordinates of the triangle. And I want you to write down the coordinates for A, B, and C. And the coordinates for A prime, B prime, and C prime. So take a second and pause this video to do that. So the coordinates for A are -8, 7. The coordinates for B are -2, 6. And the coordinates for C are -7, 3. Okay, then we need to write down our coordinates for A prime, B prime, and C prime. So the coordinates for A prime are -8, -7. The coordinates for B prime are -2, -6. And the coordinates for C prime are -7, -3. So taking a look at these coordinates, what do we notice? Well, A is -8, +7. A prime is -8, -7. B is -2, 6. B prime is -2, -6. C is -7, 3. C prime is -7, -3. What do we notice here about these? Well, we notice that our y coordinates, 7, -7, 6 becomes -6, and 3 becomes -3. So that actually brings us to our reflection rule. When we reflect over our x-axis, the rule is we are going to negate the y. So that means if the y is a positive, it becomes a negative. If the y is a negative, it becomes a positive. So we write this as the xy coordinate now becomes x, -y. So then here I have a little statement. Triangle ABC is blank to triangle A prime, B prime, C prime. What this is saying is ABC and A prime, B prime, C prime are really the same. So they are actually congruent. So reflecting doesn't change the shape or the size at all. So if side AB is 7, then side A prime, B prime is also 7, because side AB corresponds with side A prime, B prime. They have the same letters. The only thing that changes is the primes. So AB is really the same exact segment as A prime, B prime, just in a different location. All right, so let's flip over the page. Here, I'm going to reflect these all over the x-axis. So I'm going to write down my rules. When I reflect over the x-axis, the rule is to negate the y. So we keep the x the same, and we just negate the y. So let's do the first one together. And I'm also just going to write my rule as we see it as the coordinate. Xy becomes x -y when we reflect over our x. So here we're reflecting over the x-axis. So if I take a look here, I'm going to highlight my x-axis in my first example. And if I flipped ECMW over the x-axis, which quadrant would it end up in? Well, it would end up in quadrant 1. So as we're graphing, we're going to make sure we're doing that. So we're negating the y. So here I have all my coordinates. So we're going to keep all the x's the same. So I'm going to just write my x's. And I apologize, the letters, this is A, B, C, and D. So even though they're different letters, it's okay. We're still creating a reflection. So E is, that becomes A. The x stays the same. So we have 0, 1, 3, and 1. Then we're going to negate our y's. So a -1 now becomes a +1. The -1 here becomes a +1. The -3 becomes a +3. And the -3 becomes a +3. So then we are just going to graph this. So we have A is 0, 1. So that tells me I'm going 0 left and right, and I'm going 1 up, and that's going to be A. Make sure we always label. B is 1, 1. So I'm going to go 1, 1. We're going to call this B. C is going to be 3, 3. So I'm going to go 1, 2, 3, up 1, 2, 3. And then D is 1, 3. So I'm going to go 1, 1, 2, 3. And then I'm going to graph my image. forgot to label my D. So then we notice that it's the same shape, the same size, it's just reflected or flipped over. So another thing to notice is E becomes A, so that means E and A correspond. C becomes B, so C and B correspond. M becomes C, so M and C correspond. W becomes D, so W and D correspond. So now you're going to practice to try to reflect all three of these examples, and then you're just going to reflect these points by using the rule. We keep the X, we negate the Y.